So we're going to go over this practice test, which is almost identical to the test. As you can see, we have equations that have fractions in them, like number 1 right here on this practice test. And the thing to remember when it comes to equations that have fractions in them is that you could get rid of any fraction as long as you multiply everything by the denominator. Okay, so if you wanted to get rid of fractions right off the bat, you could multiply everything by 9. That way the 9 will cancel, but you'd also have to multiply 3 times 9, 2 times 9, and even this fraction by 9. Or you could think, is there anything else that I could do that'll make this equation a little bit nicer? Well, you have a number here and a number there. You could actually get rid of the -2 by adding 2 and then adding 2 over here. That way it'd cancel out and it'd become smaller. So it really depends on which road you choose to take, but there's many roads to the same place. So I'm going to start with the fractions. To get rid of fractions, a lot of people get freaked out with fractions, so let's get rid of them. I'm going to multiply everything by 9. As you could see, when I multiply a fraction times 9 or times any number, I put the number up in the numerator position, because when 9's on top and 3 is on the bottom, that's saying 9 divided by 3. And 9 divided by 3 is 3. And of course, the 3 is up on top. So I also need to consider now whatever numerator I have. So if I have 3 times something, I need to get that as a new term right here, but 3 times 1 is still 3. So 3 times 1 times d, that's 3d. And 2 times 9 right here is 18. That's a minus 18. The equal sign, of course, comes straight down. And 3 times 9 is 27. And over here, the 9 and the 9 cancel. You end up with a minus 2d. Where did I get that from? I got it right here, the minus, the 2, and the d. So now I have this equation without fractions. And of course, the goal to solve any equation is to get the variable by itself on one side of the equal sign. So as you can see, here's our equal sign. And you want to get the d by itself on one side, but the problem is that there's d's on both sides. You don't want d's on both sides, so let's get rid of one of them. I want to get rid of the minus 2d because I'd rather work with positive terms instead of negative terms. So I'm going to go plus 2d here. That'll cancel out. Plus 2d over here. My new equation will read 5d because 3 plus 2 is 5. Let's bring down everything else. The minus 18, bring down the equal sign, bring down the 27. If you haven't noticed, guys, the equal sign is like a wall. All right? I mean, if you want, go ahead and like draw a little squiggly line. That way your left side and your right side don't get mixed up. This is a great way to stay organized when solving an equation. So we have d by itself on the left side of the equal sign. Let's get it by itself. Of course, I want to get rid of the minus 18 first by adding 18. What you do to one side, you do to the other. You will have 35 over here. Let's rewrite everything. Let me rewrite it in black though. 35 on this side. The equal sign's right here. The 5d comes down. So what do I truly have right here? At the very end, I have 5 times d equals 35. Of course, I already know that 5 times 7 equals 35, so my answer is going to be 7. But let's show our work here. We want to show our work on all of our problems, especially on tests and quizzes, because even if you have the right answer and you don't have your work, you could not get credit for it. So the opposite of multiplication is division. So I'm going to divide by that same value of 5. What you do to one side, you do to the other. D equals 7. Let's move on. Number 2. Again, we have tons of fractions. And when we look at the denominator, 3, 6, 6, 3, you want to multiply everything by the LCD. Okay? I know some people get confused, but the LCD in this case is the number that the denominators could convert to. So 3 could become 6. 6 is already 6. That's your LCD. The LCD is 6. So if you multiply everything by 6, it'll get rid of all fractions at once. Now let's say you're like, oh, that's too many fractions and that's kind of confusing to me. I just want to get rid of one fraction at a time. Okay, well you could multiply this one by 3 and it'll cancel. Multiply this one by 3, it won't cancel, it'll reduce, but it won't completely cancel out. So I'm going to multiply by the LCD 6 to get rid of all fractions at once, but if you wanted to, you could just get rid of the 2/3 first and then deal with the 6 later. But I'm going to multiply everything by 6 here. 6, 6. Notice I'm writing the 6 up on top in the numerator position, because that's when you truly have 6 divided by 3 is 2. Now what do you have left over up on top? You have 2 times 2, that is 4. And of course right here the 6's cancel. 6 divided by 6 is 1, and 1 times 1 is 1. And of course with this q right here, it's going to be 1q. Or you could just put q. Let's bring down the equal sign. Let's cancel out the 6 divided by 6, that's 1. The 5 is left over with the q, no more fraction. And 6 on top divided by 3 on the bottom, that's 2. And of course that 2 is up on top. So if you multiply this 2 times that 1, it gives you 2, and it is positive. So there's our new equation without fractions. You see how easy it is to get rid of all fractions at once? All you have to do is figure out your LCD and multiply everything by your LCD. So now it goes back to our goal. What is our goal? To get q by itself on one side. And what are we talking about? What side of what? Of the equal sign. Remember, the equal sign, it's kind of like if you had a wall right here, okay? There's a left side of the equal sign and the right side of the equal sign. So where's q at? Is it on the left side or is it on the right side? It's on both sides. And you don't want it on both sides. The goal is to get the letter by itself on one side. So let's get rid of one of them. I want to get rid of this positive q. Now how could I get rid of a q? By taking it away. So we're taking away the q right there. And what you do to one side, you do to the other side. Take away 1q right here from the 5q. You can't really take away the q from the 2. Remember, like terms. Take away q's from q's. So of course q take away q is 0q, so you could just scratch it out. The 4 comes down. Of course the equal sign comes down. And the 5q take away 1q is 4q. And I can't help myself. That sounds like a bad word. 4q. Hey, 4q, man. Okay, no, sorry. Let's bring down this plus 2 right here. I know I've already said that before, 4q. So anyways, we have the q on the right side. Let's get q by itself. We're going to get rid of that plus 2 by subtracting 2. What you do to one side, you do to the other. You have 4 take away 2, which is 2. Bring down the equal sign, bring down the 4q. No more bad words. And let's get rid of the multiplication of 4 with the q by dividing by 4, the opposite of multiplying by 4. What you do to one side, you do to the other side. Yes, 4 divided by 4 is 1, so that cancels out. You really just have a 1q, or just q right there. And so many people get confused right here. Remember, the top number is the one that's being divided by the bottom number. 2 divided by 4, you can't do it. You could divide 4 by 2, but 4 is not up on top. It's 2 that's up on top, so it's really 2 divided by 4. You can't really divide, so we are going to just reduce the 2 over 4. We're going to reduce by 2. That'll give us a 1 up on top, and reduce by 2 on the bottom. That'll give us a 2 on the bottom. So q is really 1/2. I would write it q equals 1/2 instead of 1/2 equals q. Let's move on. Looking at this whole front page, instead of jumping to number 3 right now, let's jump over to number 5. The reason why is because we've been dealing with nothing but equations that have fractions in them. We might as well continue with number 5 because it has a fraction in it. So of course, if you want to get rid of this fraction, you'd have to multiply everything by 4. Now one option is to take the 1/4 and distribute it to both terms, right? That's an option right there. Or another option is to get rid of the 1/4. In other words, wouldn't it be nice, instead of distributing 1/4 into the parentheses, wouldn't it be nice if you just could erase this divided by 4 and just have a 1 that you're distributing in? Because 1 times 3g is 3g and 1 times -4 is -4. So it'd be really easy if it were just a 1, but it's not just a 1. It's 1/4. So let's get rid of the 1/4. So in other words, I want to get rid of this divided by 4. How do I get rid of something? By doing the opposite. What is the opposite of dividing by 4? Multiplying by 4. Okay. And of course, what I do to one side of the equation, I must do to the other side. In other words, I need to do it to every single term on the equation. So if you're thinking, yeah, you multiply this by 4, you're not going to multiply these guys by 4, because it's kind of like if they're protected by these parentheses. You see, the thing is, whatever you do to this outside term, you know that there's going to be distribution. So whatever you do to this outside guy, it's like if you already did it to these inside guys. Okay? So the only other term you actually have to multiply it by is the g divided by 4 over there on the other side. So once again, let's compare this one over here. Right here, I wanted to get rid of the 9 on number 1. So I multiplied this fraction times 9, the 3 times 9, the 2 times 9, the 1/3 d times 9. I multiplied every single term on this equation by 9. Now, on this one, I also multiplied every single term by 4. But it just doesn't look like it. Why? Because there's parentheses right here. Okay, so when I multiply the 1/4 by 4, because of distributive property, it's like if I already multiplied these guys by 4. So it would be incorrect to go and multiply it again by 4 and getting a 12g right here. That'd be incorrect. Okay, just remember, whatever you do to this outside guy, it's like if you already did it to these inside guys. So 4 and 4 cancel out. So now you really do have that 1 that you need to distribute. And I might as well look over here at the 4 and the 4 cancel. So let's cancel that out, and let's bring down the g. So you see, now we got rid of all the fractions. And of course, if you were to distribute the 1, it doesn't change anything. It's going to be the same exact thing. So let me rewrite this equation. The 3g minus 4 without the parentheses, without the times 1, equals g. Once again, the goal to solve any equation is to get the variable by itself on one side, but the problem is you have g's on both sides of the equal sign. Again, it may help you to draw a little wall to show you the left side of the equal sign and the right side of the equal sign. So you want to get the g on one side. Now imagine if I moved this g, if I subtracted g here and subtracted g over here, there would be nothing here, and I would have g, and g is not by itself. The goal is to get g by itself on one side. So it'd be easier, I mean, you could do it that way if you'd like, but it'd be easier to get rid of this minus, or the 3g by doing a minus 3g, it canceling out, and what you do to one side, you do to the other. Then you're going to have a negative 4 on the left side, the equal sign. G take away 3g is negative 2g. So for my final step, I'm going to go negative 2 times g. I'm going to get rid of the multiplication of negative 2 by dividing by negative 2. And what I do to one side, I do to the other side, divide by negative 2. So my final answer is g on the right side equals positive 2. So I would write it g equals positive 2. You know, I guess right now is a good time, since we're on the front page, it's a good time to stop right here, because we did the 3 equations that actually dealt with fractions. And keep in mind, it's best to multiply by your LCD. Okay, so when you look at multiple denominators, 3 and 6, go with the bigger one, especially if it's a common denominator. And that way you can get rid of all fractions at once. And remember, if you have parentheses and you're supposed to distribute a fraction into there, you could get rid of the fraction, but don't multiply the inside by that denominator 4, because it's kind of like these parentheses are protecting them. Remember, whatever you do to this outside guy, it's like if you already did it to the inside guys because of distributive property. We'll pick up right there on the next video.